All right, today we're going to be looking at second chapter, excuse me, which is a lot. We're going to be getting into just these systems of equations. So today we're going to be starting by talking about systems of equations. These two pictures each show two different equations. And so when you get more than one equation, it's a system. And then you can kind of visually, hopefully, see where the solution is to each equation. This two equations happens to have one solution. It's at the point 1, 2, and you'd say, okay, the solution here is 1, 2. This one here actually has two solutions. And I just kind of wanted to point that out just to show that the pictures were of systems. So hopefully by the end of hearing this lecture, you're going to have three things that you can say, yep, I can probably do all three of these. I can solve a system of equations using an elimination method, solve a system of equations using the substitution method, and then solving by graphing. Now this should be review because it's definitely something that's covered in Algebra 2, but I think it's worth reviewing. So our whole point is what's here in the top is our system of equations. It's a set of two or more equations. Either there's one solution, so there's intersecting lines. No solutions, we have parallel lines, or infinite solutions, which means they're right on top of each other. Now this is true when we have linear equations. Now we had a picture at the beginning where we didn't have both of them linear. Now when we have a quadratic and a linear, that's when you can get two solutions. But when both of them are linear, these are the options: one solution, no solutions, or infinite solutions. So now let's look at our first example here. Now the first example, what I want you to do is I want you to look at and decide how can we do this by graphing. I'm going to try to get a nice big graph in here because it's helpful to have a big graph. So our first equation is 3x minus 2y equals -6. And we learned in chapter 1 it really helps if we solve these for y. So I'm going to subtract 3x from both sides to start with. I'm dividing each and every term by 2 here. So this is what I get when I divide each and every term by 2. So I'm going to go ahead and graph. I'm going to call it my blue line. I'm going to graph it in blue, and we're going to see what it looks like here. So here is +3. From there, I'm going to go up 3 over 2. Here's another one, up 3 over 2. Here's my line. So there is a nice straight, my blue line. I'm going to do the other one in red. So now I'm going to simplify my second line, and I'm going to subtract subtract x from both sides. Now I'm going to graph my red line. I'm down here at -2, and now I go down 1, right 1, down 1, right 1, or up 1, up 1. And I'm looking to say, oh, it looks like I didn't cross at a really nice point. I have a feeling that has to do with a little sloppy line drawing on my part. Let me see if from this point I can go, yep, it is a little sloppy, down 1, down, oh, wait a minute, let me see something. So what I'm looking at is I'm going to see, can I get my line a little bit crisper, a little bit better. From this line, if you remember, our slope was 3/2. So if I go down 3 and over 2, I'd be right here, down 3 and over 2. Now I can see that, yep, I needed a little bit better line. There's my nice blue line. Here's my nice red line. And we can see exactly where they cross. They cross at the point of -2, 0. That is my solution to my equation. So in graphing, our solution is just a visual point where you can see the lines cross. Now we're going to solve by using the elimination method. In the elimination method, we're trying to eliminate either our x terms or our y terms. When I look at the two equations that are in front of me, 15x plus 2y equals 20, 25x minus 5y equals a -25. And I'm looking to say, is it easy to eliminate one or the other? I don't think so. I think what I'm going to do is I'm going to multiply both the numerator and the denominator by a different value. So I'm going to choose to multiply my numerator. I'm going to multiply my numerator here by a +5. And you'll see why in a minute. So when I multiply by 5, 5 times 15 is 75x plus 10y equals 100. I'm going to multiply my second equation by 2. I'm going to double everything. There I get 50x minus 10y equals -50. Now, the reason why that was a kind of a smart thing to do right there, Um, it's because now I can look at this and I see that here in my 10y's, I have a positive 10y and a negative 10y. So if I add those two together, I'm going to get a 0y. And so that's what the elimination method is about. It's about multiplying the whole equation by a value so that in the end, when we add both sets of equations together, one of them becomes a 0. And so when it's 0, I'm not even going to write it down. And so then right here, what I would do is I just divide both sides by 125. And my x would be 2/5. So I found my x to be 2/5. Once I have my x, I can use that answer to take it back, and I can use either equation. I know that 15 times my x plus 2 times my y equals 20. Now I can substitute in, instead of this x, I'm going to put in, we know the answer here, or for our point that it meets, is 2/5. So I'm going to try to work that out. So here, 15 divided by this 5 right here is a 3. So I really have 6 plus 2y equals 20. I'm going to go up here to solve the rest of it. 2y then would equal 14, and y must equal 7. So the solution to my equation was the point 2/5, 7. That's my solution. That's the point where these two lines will cross. It's the point that they have in common. Let's now look at what it looks like for the substitution method. Now in the substitution method, we usually have the situation where they tell us, like in this case, that x can be replaced with y plus 2. All right, it's kind of a little bit like composition now. So what we have is in this equation, 2x plus 3y equals 8. We found that our y can be replaced with, or excuse me, it's our x that can be replaced. I need to move things. Sorry about that, guys. Our x is what can be replaced with a y plus 2. All right, and that's what our x is, and we have everything else kind of stays the same. Because that statement I circled in yellow here tells us that x is the same thing as the value y plus 2. Now we just simplify 2y plus 4 plus 3y equals 8. Therefore, 5y plus 4 equals 8. 5y equals 4. Y must equal 4/5. Okay, well, we found part of them. Y equals 4/5. Well, if x, and this is just from one of my original equations, what I have circled in yellow, equals y plus 2, our x must equal 4/5 plus 2. To add together 4/5 and 2, I am going to make 2 the same thing as 10/5, because 10 divided by 5 is 2. So my x in the end is 14/5. My point, my solution, is 14/5, 4/5. And so I think the fact that we have fractions here just shows that we're kind of dealing with a little bit more complex numbers in pre-calculus than you might have seen in Algebra 2. So just to review, all right, and these are just to kind of check yourself. It might be a really good idea right now to pause the video and then see if you can get these 3 questions answered, and it's just 3 questions from your assignment, and then play it again and see if you got it right. So on number 5, I'm going to make the first one my blue equation. I'd go to -2. My slope is 5, 1, 2, 3, 4, 5 over 1. Down 1, 2, 3, 4, 5 over 1. And I'd make my nice line. Oh, that's not such a nice line, but we know. Oh, we'll work it there. There we go. All right, next one. I'll do this one in red. Up 5, 1, 2, 3, 4, 5. Oh, that's not 5. I got to move that. Sorry. 4, 1, 2, 3, 4, 5 right there. From there, I'm down 2 over 1. I can see what we have in common already. That's kind of nice. So I can see what I have in common right here is this point 1, 3. That is my solution to this problem. Let's go down and solve our other problems here. Next one, we're solving our system of equations. What I would do for this equations is I'd multiply everything in this equation by 2. By doing that, now I have 12x minus 4y equals 6. Now the the top equation actually doesn't need to be multiplied by anything, because if I just copy it down, I'm just copying it here. Now I have the 4y's can be cancel out, or not cancel out, add up to 0 when I add my columns. So I'm going to add my first column, I get 15x equals 5. Therefore, my x equals 1/3. If I divide both sides by 15, be careful there that you don't say that the x equals a 3. We're dividing both sides by the 15 to get x all by itself. In this second equation, I'm looking here to say, hey, my y can be replaced with a 6 minus an x. So wherever there's a y, I can replace it with a 6 minus an x. My x could have also been replaced with a 4.5 plus y. It really doesn't matter which direction you go. So what I'm going to do is I'm just going to write this second equation, x equals 4.5 plus, and then instead of having the y, I'm going to write 6 minus x. The 4.5 plus the 6 is 10.5 minus x. When I add x to both sides, I get 2x equals 10.5. Divide both sides by 2. X equals 5.25. So I got for an answer of a common 5.25 and 1/3. You could put 0.33 for the 1/3. I'm going to leave it as 1/3. I know we found a fraction and a decimal, and technically that's not lovely. Oh, I went to the wrong place. Oh. I'm realizing that I'm just realizing what I did here. Oh my gosh. All right. What I did wrong is I had this x equals a negative 1 or equals 1/3, and I didn't go back and solve for y. So this, I kind of mixed my two different problems together. This is actually not right. Sorry about that, guys. So I need to go back and I need to take this and I need to solve it for the y. So I could have used either equation here. It really doesn't matter which. I'll just use the first. The 3 times whatever we find for x plus 4y equals a negative 1. This would be just 1. So if I subtracted 1 for both sides, 4y equals negative 2, and y equals negative 1/2. So this answer is 1/3 comma 1/2. That's my answer here. That's my ordered pair, excuse me. Here, I have to take this 5.2 and put it back into one of these. I'm going to say y then equals 6 minus 5.25, which means y would equal 0.75. Now that sounds better. I was thinking, how did I get fractions and decimals? Now I know what I did wrong. There we go. So, common mistake apparently, that you're going to, once you get an answer, you're not done. You only can't get one of the x's, you need the x and the y. So don't forget to go back. Don't do what I do, do better than I do. So your assignment is right here. So it's on page 69. These are great problems to go through. So if you don't have your book with you, it's all right here. The problems I want you to do are 5, 6, 7, and 8, 14, 15, and then 22, 23, 24, and 25. Thank you.